In this video, we're going to take a look at our first example of jointly continuous random variables. So let's jump in. Suppose that a radioactive particle is randomly located in a square with sides of unit length. That is, if two regions within the unit square and of equal area are considered, the particle is equally likely to be in either region. Let y1 and y2 denote the coordinates of the particle's location. A reasonable model for the relative frequency histogram of y1 and y2 is shown here. Right? So right here, this is our reasonable model that says the density is 1 as long as our value of y1 and y2 are both between 0 and 1. And if either one of them is outside of those, outside of 0 and 1, then we're going to have a density of 0. Right? So the first thing we're going to do is we're going to just sketch this surface. I'm terrible at drawing surfaces. I'm terrible at drawing in general, but let's give it a try. So I have down here, here's our y1 axis, and here's our y2 axis. That vertical line, that's going to represent the output of our function, little f of y1, y2, that density function, right? So that's that axis. So as long as our value of y1 is between 0 and 1, we should be at 1. Right? As long as we also have our value of y2 being between 0 and 1. And if we exceed either of those or go down below either of those, then we should run into problems. And so really what we have here is this surface right here. And so that surface is just like the top part of that box. So it's 1 there, and everywhere else we're going to be at 0. So that's our surface. It's 0 everywhere except for when both y1 and y2 are between 0 and 1. All right, so let's find some probabilities. All right, so f of 0.2 comma 0.4, we would have this. We're going to all right, so from our previous page, we said that f of y1, y2 is a negative infinity to y1, and so here in this case, that value of y1 is 0.2, and then our value of y2 is going to be 0.4, right? And so we have an integral from negative infinity to 0.2, an integral from negative infinity to 0.4. F of, here we don't need to use a dummy variable because we have the actual values of y1 and y2, so we can keep them as f of y1, y2, dy2, dy1. Now, we only have non-zero values when our value of y1 and y2 are between 0 and 1, and so we can restrict this, or we can simplify this to being an integral from 0 to 0.2 and 0 to 0.4. And that function y1, y2 in those ranges will just be 1. And so what we're first going to do is we are going to work with the inside of this integral. And we are going to integrate with respect to y2. And this is the function, just the function 1. We are integrating with respect to y2. And so when we integrate that, we're going to get, so that value of 1 is going to integrate to just y2. And that's going to be evaluated from 0 to 0.4. And so we get an integral from 0 to 0.2 of 0.4 dy1. And then we're going to integrate with respect to y1. And so we get 0.4 y1 evaluated from 0 to 0.2. And when we substitute in, we get 0.08. And so what that's really looking at is the density of the curve, or the volume of the curve, just when we restrict our values of y1 to being between 0 and 0.2, and our values of y2 being between 0 and 0.4. And we can do other things. We can look at other examples, and it should work more or less the same way. So here we want to find what is the probability that y1 lives in this range and y2 lives in this range. And to find those probabilities, that's really just a fancy way to ask us to find some more double integrals. Right? So we want to find the integral, so our value of y1, the lower value, we're going to go from 0.1 up to 0.3. Our value for y2 is going to go from 0 to 0.5. Our density is 1 in that range. y2 is the inside limits, and y1 is the outside. And so when we integrate the inside, we have 0.1, 0.3, y2 evaluated from 0 to 0.5, dy1. And then we need to integrate with respect to y1, and we do that again. Integrating a constant, we'll just integrate to that constant times the variable y1, and we're evaluating that from 0.1 to 0.3. Oh, and so if we do this, we end up with 0.5 times 0.3 minus 0.1, which is 0.01. All right, so that is our first example there. We'll take a look at another one in the next video.